Hi everyone, and welcome back to another AP Calculus video. Today we're going to talk about a technique for integration called separation of variables. And this is a technique that we use when we have an equation, a differential equation in particular, that has more than just the variable x floating around in it. So what we do is we are differentiating, or we have a derivative, right? So a differential equation is an equation involving a derivative. So we start with a differential equation like what we have shown here. And you'll notice that dy dx, so the derivative of y with respect to x, involves both the variable x and the variable y. So oftentimes these sorts of differential equations come about because of implicit differentiation, which is a technique we learned when we were finding derivatives that involved taking the derivative of an implicit function. In other words, a function that wasn't clearly defined as y equals and then some function of x. So a lot of times conic sections will come to mind, and those sorts of functions will be, will result in a derivative like this. So then how do we undo that? So we're going to find what's called the particular solution. The particular solution means solve the initial value problem. It means you have to find C. So anytime you see instructions that involve finding a particular solution, or particular, depending on how you pronounce that word, that means you're going to solve for C. So you're going to have an equation, and the plus C will be there. You'll always be given an initial value. So it's an initial value problem. One of the things that we'll learn here that comes up in this unit is the concept of slope fields. And so depending on the order in which you're watching the video, if you're watching them the way that I teach my class, I haven't shown my students what slope fields are yet. And what a slope field does is it says, hey, if I have a differential equation, knowing that these functions, there's an infinite number of solutions, all differing by that constant, what a slope field does is it shows us a picture of those solutions, of the infinite number of solutions. And then once we know an initial value, then we have one and only particular solution. So that's coming from my classes later on. But let's talk about how we would do this. First things first, anytime I have a function like this, I want to be able to separate the x and the y. That's ultimately my goal. That's why this is called separation of variables. My goal is to put everything related to y on one side, everything related to x on the other. So in order to do that, I have to rewrite this equation right off the bat as x squared y squared. I'm going to distribute that exponent. I'm going to put it to everything inside that product. So now what I do is I separate my variables. And when I separate my variables, I want to put everything related to y on the left-hand side. I want to put everything related to x on the right-hand side. The reason I want to do that, and the reason why it has to be that way, is because what I'm going to do right off the bat is I'm going to take this dy dx and I'm going to split it up by multiplying the dx to both sides. So what happens here is I get this equation. I get dy equals x squared y squared dx. Now, it doesn't do to try to put x on the left-hand side because I needed to multiply the dx over to the right. And the way that I have it set up, this is the way that it's going to go. In order to move y to the other side, I am only allowed to use multiplication or division. I cannot use addition or subtraction. And we're going to see in a couple of examples here later on in the video is that there are going to be times when it's going to be very tempting to add y over. You cannot add y or subtract y to move it to that left-hand side. You must use multiplication or division. So I'm going to divide by y squared here. And when I do, I get this. I'm going to write it as 1 over y squared dy equals x squared dx. So now I'm set up. I've done what's called separating my variables. And in an AP exam free response question, this step alone could be worth just as, one of the many points that you can get for a problem like this. Oftentimes these types of problems are worth 4 or 5 points. One of the points always comes from separating your variables properly. Another 1 to 2 points comes from finding the antiderivatives, which is our next step. So once we separate our variables, we throw an integral sign around everything, and then we integrate. We find those antiderivatives. So the 1 over y squared, remember this is y to the negative 2 power. So when I find its antiderivative, it's not going to involve natural log, so be very careful about that. So this becomes y to the negative 1 over negative 1. equals, this becomes x cubed over 3, and then I'm going to add a constant. Now, technically, I'll have a constant for both integrals, but what I do is I assume that whatever constant I have on the left, I'm just going to add or subtract it over to the right-hand side. So really, we just put the plus c typically with the x side, knowing that whatever constant was on the left, we were going to move it over anyway. So we just say plus c. So now I'm going to keep on going. I'm going to have -1 over y equals x cubed over 3 plus c. Now, more often than not, these problems, you only get credit when you solve them for y. So you need to have the particular solution y equals. Now, we're not quite ready for that yet because it said, hey, find the particular solution. So what we're going to do before we solve for y is we're going to find c. And if I go back up to the original problem, it said y is 1 when x is 1. So I'm going to use that information right here, right now. So again, don't solve for y until you've found that constant. So we know when x is 1, y equals 1. So I'm going to plug those numbers in. -1 over 1 equals 1 cubed over 3 plus c. So -1, when I subtract the 1/3, that gives me 4/3, -4/3 equals c. So right now, my particular solution looks like this. -1 over y equals x cubed over 3 minus 4/3. Now, what I'm going to do is I'm going to solve for y. That's always going to be a step that I'm expected to do on a free response question on my AP exam. So having this -1 over y, this is not acceptable at this point. So we need to clear that up. We need to do some algebra. So what I'm going to do, anytime I have fractions, one fraction is always better than two fractions. So I'm going to combine these terms together. Okay. And now it should be actually pretty easy to solve, because if I cross multiply, or if I multiply by y and then divide, depending on how you like to think about your math. I know a lot of math teachers don't like to use the word cross multiply. I think it's perfectly fine. So if I cross multiply and divide, essentially I'll be able to solve for y. I can also realize that when I have fractions, the easiest thing to do with the fractions is if I have, a over b equals c over d, then proportionally speaking, because I've set up a proportion here, a proportion is one fraction equals another fraction, I can actually flip both sides and be just fine. So if I flip both sides, because now I'm thinking proportionally, this is a proportional relationship, 3 over x squared minus 4, boom, I've just flipped everything. It's all hunky-dory. Multiply the -1 over, and we get our final answer. -3 over x squared minus 4. And this would be more than likely what you would find listed in a multiple choice option on an AP exam. This would be the answer that you'd be looking for on a free response. You have to solve for y. You've got to get it looking like y equals on a problem like this. That's the particular solution. Now, in the middle, you can get credit for antiderivatives, for solving for c. That's often worth a point. So even if you don't successfully solve for y in the end, you can still get a majority of the points on a problem like this. So let's keep going. Let's continue using our integration technique here, our separation of variables, and see if we can kind of remember the steps as we go along. So step number 1 is to separate your variables. We're going to put the y's on one side and the x's on the other. We're going to use multiplication or division to do that. So dy, I'm going to multiply by y, and then I'm going to multiply by dx to get everything moved around. So I'm going to have y times dy, when I multiply the y over, equals x cubed dx. So separating your variables, understanding that you are using multiplication or division to undo the y, that is key right here, because there's a lot of people who will just move it over accidentally, not realizing that, oh, the way that I move y over to the other side is through multiplication here. A lot of people will forget that, and actually it happens more often when you have a problem like this, where you have xy. I have a lot of people who will write y dy equals x dx, and that's just not true. So you would need to make sure that you're really paying attention to what operations you're using to manipulate your variables and move them to the proper side. So let's keep going. Now I'm ready to integrate. I'm going to do the integral of each side. This is going to be y squared over 2 equals x to the 4th over 4 plus c. Always do your plus c. Now, generally speaking, if it's an initial value problem like we have here, it tells us y is 2 when x is 1. We're finding the particular solution. That means we're finding the value of that constant. We're solving the initial value problem. I always do that step right away. Oftentimes, it's the easiest to solve for c right off the bat. So don't solve for y yet. So here we go. What is c? Well, if y is 2, then we're going to have 4 over 2 equals x is 1/4. So this is going to be 2 equals 1/4 plus c. So the equivalent of 2, that's going to be 8/4, right? So 7/4 equals c. I found the value of my constant. Now I'm ready. I'm going to go back over here and I'm going to start writing down y squared over 2 equals x to the 4th over 4 plus 7/4. Alrighty. So now I'm going to solve for y. So here we go. Y squared over 2 equals x to the 4th plus 7 over 4. Multiply both sides by 2. It's going to reduce this to a 2. So I get y squared equals x to the 4th plus 7 over 2. And then when I square root, because I have to solve for y, watch what happens. I get y equals plus or minus the square root of x to the 4th plus 7 all over 2. Now, here's where it gets tricky. This says y equals plus or minus. But we also know a little bit of information up here. We're given an initial value, y of 2, or y equals 2 when x is 1. So let's take a little journey here. Let's do a little aside. If I go over here and if I plug 1 in, if I find y of 1, and I say it's equal to plus or minus the square root of, let's see, 1 to the 4th plus 7 over 2. Okay, well that's going to be the square root of 8 over 2, that's plus or minus, that's going to be plus or minus the square root of 4, that's plus or minus 2. Y of 1 is not positive or negative 2, it is simply 2. So what this tells me is that plus or minus, I have to choose one. And if I'm given the initial condition, when I plug a number in, I got a positive answer back. That tells me that I can throw away the negative. All right, so we can throw away the negative because y of 1 equals positive 2. Our initial condition tells us we'll get a positive result. We're not going to get a negative result. So I'm going to throw that away, and my final answer needs to drop the plus or minus and include the appropriate sign. Now, sometimes y of 1, sometimes your initial condition will give you a negative value. And if that's the case, well, then you would drop the positive sign. You have to look and analyze your initial condition, apply it to your answer, and choose the appropriate course. So here, y is going to be positive x to the 4th plus 7 over 2. And that's my final answer. That's the answer that I'll be looking for. So be really careful about those initial conditions and what they tell you are happening in your problem. So let's keep going. Let's see a couple more. So we want to find the particular solution that passes through the point 0,3 for this particular problem. All right, so here we go. We're going to solve our initial value problem. We're going to separate our variables using multiplication or division. So I'm going to multiply dx over, but I'm going to divide the y over to the other side. So I have to divide by y. And when I divide by y, it's in the bottom of a fraction. If you don't have a number in the problem, it's a 1. Remember, you always have a 1 floating around in every problem. So this becomes 1 over y dy equals 4x dx. Okay, well now I'm ready to integrate. I got this. I can do this. You can too. I'm going to integrate. Oh, this becomes the natural log of the absolute value of y. Remember those absolute value bars. That's critical here. Remember, the whole point behind the absolute value bars is that in the original function, y could be any number, positive or negative. So we have to put absolute value bars around it to get rid of those negative values because they're not in the domain for natural log. So here we go. All right, I found my antiderivatives. You guys, if this was a free response problem on an AP exam, I'd probably have 3 points by now because I remembered to do plus c. So now I am ready to solve for my plus c. Okay. Here we go. When I solve for my plus c, there's a couple ways to kind of go about this. Now, I'm struggling with solving for my plus c because as I look at this, I'm thrown off by those absolute value bars. And I don't really like them, and sometimes they'll work. Sometimes I can solve for c here, but sometimes I can't. So when I have absolute value involved, it's always better to solve for y first and then find your c. I know in the previous examples I said, hey, solve for c right away. When absolute value is involved, it's better to get rid of the absolute value bars before we go trying to solve for any constants. So how do I solve for this? Well, the first thing I'm going to do is I'm going to rewrite it like this, 2x squared plus c. And then when I solve a natural log problem, I'm going to raise both sides as an exponent of e. That's really what I'm doing. Because remember, natural log is log base e. So when I raise e to the ln, it cancels away, and you're left with whatever you're taking the log of. So e to the log base e of x would just be x. So it's a notation that we're dealing with. So I'm going to raise each side as an exponent of e. So now what I'm going to have is the natural log and e will cancel away, and I'll be left with the absolute value of y equals. Now watch what I do here with this right-hand side, and convince yourself that it's okay. I'm going to have e to the 2x squared times e to the c. So when I have two exponents, for example, when I have x squared times x cubed, we know that we can add those exponents together to get our equivalent form. That's a rule we have with exponents. So if I have x to the 2 plus 3, I can split them up into two like bases. I can go the other direction. Now we're not used to going that direction here, but that's what I've done here. As I've said, oh, I've added two exponents together. They must have come from two like bases being multiplied. That's what that rule is telling me. So this is a really great trick because now watch what I can do. When I drop my absolute value bars, this is when I have to put that plus or minus in there. And I'm going to put the e to the c in the front, wrap it up in parentheses. This is my new constant, you guys. E is a number like pi. So 2.718 on to infinity to the c power, that's my new constant, times e to the 2x squared. Now, here's the deal. I'm going to take this plus or minus e to the c, and I'm going to solve for that, okay? And the way that sometimes I can come over here, and if I have to write it a lot, I'm going to give it a new name. Let k equal this plus or minus e to the c power. Sometimes you don't want to write plus or minus e to the c. You can redefine it. As long as you write it down clearly for the AP graders to see, you can redefine it as whatever the heck you want. So I can rewrite this with just the letter k here. Ta-da! That's not so bad. Now I'm ready to solve for that k. So I'm going to use my initial condition. So recall, the initial condition was this, y equals 3 when x equals 0. So I'm going to plug those in. So y is 3. This becomes e to 0. That becomes 1. So, oh, k is 3. Look at that. Boom. That was easy. So that's my plus or minus, and it turns out it's a plus. And now I'm ready to write my final answer. My final answer looks like this. Y equals 3e to the 2x squared. That is what I'll be looking for. That's the answer we want. Okay? So let's keep going here. Let's do a couple of more, just so that we can be thorough and see all kinds of examples. Now, this will be our last one that we do here. And recall in the beginning, when we were first learning about separating our variables and talking about that, I said, you can only use multiplication or division to separate your variables. And I said there's going to come a time when people are going to be really tempted to use addition or subtraction to separate your variables. And I could see a lot of people looking at this saying, oh, I want to subtract y and then divide by y. And you get this weird convoluted situation where you get 1 on one side and x on the other. That's just not the way that you can do this. The only way to solve by separation of variables, the only way to separate your variables is through multiplication or division. So then what do we do here? Well, we have to be a little more creative with our setup. We may have to rewrite it in a way that's workable. And I notice that I have a y here in both terms. So what I'm going to do is I'm going to separate out my variables. And I'm going to write this problem like this. Now I have something factored out. I can divide out that y. So when I divide both sides by y, and put the dx on the other side, I get 1 over y dy equals x plus 1 dx. Now I'm ready to integrate both sides with respect to their variables. So integrate, here we go. Natural log of the absolute value of y equals x squared over 2 plus x plus c. All right, here we go. This is going to be another one of those e to the whatever problems where we're going to have to solve for our constant a little bit later on because we have that absolute value of y. So let's raise both sides as a power of e. So we'll get the absolute value of y equals, I'm going to put my e to the c in the beginning, times e to the x squared over 2 plus x. I'll leave those together. But I want to pull that e to the c out. And when I drop my absolute value bars, that's when I get my plus or minus e to the c times e to the x squared over 2 plus x. Now, in the previous example, I said, oh, let's let k equal, so we didn't have to write it. Well, truthfully, I'm not going to do that in this one, so you can see how it plays out. But essentially, here's what we do. We go back up here and we say, well, did we have an initial value problem? Oh, and the answer was no. So we did not have an initial value problem here. We're not given anything about what c is, so we'll just kind of go ahead and define it. In this case, I changed my mind. I will let k equal plus or minus e to the c, and I'm going to rewrite it as y equals k times e to the x squared over 2 plus x. Now, because it's not an initial value problem, and now that I'm at the end, as I look back, no initial conditions were given, and that's okay. But now that I'm at the end, I can't solve for k, so I'm just going to leave it. And this is actually the answer that I would give. This is my final answer. If I had an initial condition, I'd solve for k, but I don't. So this is where I'm going to leave it. And the key here, and the thing I want you to take away from this example, is less the end result of having k in the answer and more the beginning where we separated our variables and we had to factor out the y so we could divide it. Remember, you cannot add or subtract when separating your variables. You must use division or multiplication. So the more you do of these, the better you're going to get. You have to know how to do this. Oftentimes they show up on a free response and it's worth 4 to 5, sometimes even 6 points depending on the difficulty of the problem. So knowing how to do this process is pretty critical. So practice it up, reach out for help, and the more you do, the better you're going to get at these types of problems. So don't give up. You can do this. You've got this.